Hi, in this lesson we will introduce two different kinds of measurements, vectors and scalars. Let's start with an example. We have two soccer players standing right next to each other. The player without the ball then runs 3 yards to the right, turns and runs an additional 4 yards down. She is about to receive a pass from the first player, so the question is, how far away are the two players? Or how long will the pass be? Is it 7 yards? If we add the two legs of her run, that's the total distance. But maybe you can see that they are not actually 7 yards apart. In fact, they are only 5 yards away from each other. There are two measurements here. One, the distance she traveled, which we know is 3 yards plus 4 yards equaling 7 yards. But if we add pieces in a slightly different way, 3 yards to the right plus 4 yards down, the answer is 5 yards and to the right. We call this measurement the displacement, which is how far and in what direction is she from where she started. Each piece of this is a displacement. 3 yards to the right plus 4 yards down equals 5 yards down and to the right. The distance measurement doesn't care about direction. Just add the lengths or magnitudes of the pieces to get the final result. We call this type of measurement a scalar measurement. In contrast, in order to get her displacement, we needed to consider both the magnitudes and directions of the pieces in order to get the final result. We can't just add them together to get a total. You can imagine if she changes the direction of her second run slightly. Her final displacement will be larger than 5 yards. So direction matters for displacement. We call these types of measurements, those that have a direction associated with them, vectors. So two types of measurements, vectors and scalars. Vectors have a magnitude or length and direction associated with them, whereas scalars just have a magnitude. Let's take a look at this list of measurements. Pause the video for a moment and decide which of these are scalars and which are vectors. How'd you do? The key question to ask is, does it have a direction? Force, velocity, and momentum all can be in a certain direction, left, right, north, or south. You can say, my momentum carried me forward on the sled, or the force of the collision pushed me backward. Money, energy, speed, mass, volume, and height just have a number associated with them, but no direction. For example, your speedometer in your car just tells you a value of speed, not a direction. Because vectors have a size and direction, we often represent them as arrows. The length of the arrow is the magnitude, while the angle relative to an axis measures the direction. When we say magnitude, we really just mean the size of the measurement. For example, let's say this vector is a velocity of a car going 10 miles per hour northeast. The magnitude of the vector is the 10 miles per hour. We can also talk about the x and y components of the vector, which is another way to describe both the magnitude and direction. Its x component is telling us how fast the car is going to the east, 6 miles per hour. And its y component is telling us how fast it is moving north, 8 miles per hour. By driving 10 miles per hour northeast, it is going both 6 miles per hour east and 8 miles per hour north at the same time. That's what our components can tell us. And because, of course, this is a right triangle between the vector and its x and y components, we'll be able to use trigonometry, which we'll go over in future lessons. The key takeaway here is that as we work with vectors, both in our calculations and when we program with them, we need to treat them differently than we would our ordinary scalar measurements. Awesome! Now it's your turn to start working with vectors.